People, men and women, people of different talents, working together in different ways, working with each other and machines, make things happen. The high-energy ignition plant is one of these happenings. Computer-controlled material storage systems serve the high-energy ignition distributor plant and facilitates inventory control for plants who must import most of their parts. The storage system control room dispatches material over a network of delivery points. Computer link-up and voice communication with the production floor make an efficient team. The heart of the high-energy ignition system is the secondary winding of the high-voltage ignition coil. Coils are wound on fiber tubing 20 units wide. Each operator easily tends 8 of these automatic winders. Over 1 mile of human hair-size wire is used in each coil and winds at 1,500 feet per minute. Many inner leaves of paper are required during the 10-minute winding cycle. The wire turns must be perfectly spaced to allow potting resin to thoroughly wet and insulate the coil, which will develop 40,000 volts in service. The machines designed and developed at Delcotron are the finest in the world, and when placed in production, reached levels of efficiency almost double that expected. Following coil winding completion, the coil tube must be separated by laser beam, cleanly and without burrs. An absolute dryness and openness of the winding layers is required. Trapped moisture-bearing air between the layers of coil wires must be completely displaced. Rotating coil tubes are separated into 20 coils by laser beams and prevent damage to the many layers of fine wire. A delicate operation after separation and before potting is fastening the high-voltage belly button contact tab to the hair wire. Finished assembled coils must be potted in low-viscosity epoxy resin. Placed in plastic trays, the resin submerges all but the white center towers. To remove all traces of moisture and air, the coils must be vacuum treated to allow air to escape upwards through the resin. After curing, the coils are separated from each other by removing the rim of the potting tray. The rest of the tray left surrounding the coil forms a protective case. E-laminations are assembled into the coils, and mounting brackets are formed and attached on inline assembly machines. The machines attach clips to the coil leads and perform inspection operations to maintain a high quality level. The cap of the high voltage distributor is injection molded in computer controlled molding machines to maintain precise control over the many molding variables. The process is automatic with raw plastic feed conveyors and molded cap exit conveyors. Syntron feeders feed aluminum high voltage contact blades that must be assembled into the caps. They are placed into holding jigs which align them precisely so that they may enter the molded holes in the cap. These machines regularly achieve efficiencies over 95%. Caps are hand-placed on the contact blades to minimize cap damage. High-voltage aluminum terminal bushings are fed downwards around the blade tangs and into the cap. The projecting blade tangs are spin-riveted to firmly fasten the bushing to the blade with a minimum of pressure. High-voltage ignition coils are placed into the completed caps from parallel feed tracks. The cap covers are placed over the coil, completing the assembly of the cap. Automated placers are under construction. HEI distributor base units are pre-assembled and delivered for shaft and rotor subassembly by gravity drive pallets. Following the shaft subassembly, the base units are elevated for delivery to the final assembly lines. The heavy coils assembled into the relatively fragile caps require careful handling prior to and during assembly. Finished assemblies must undergo final testing. Special conveying techniques transport and firmly support the top-heavy assemblies. Ignition is a critical performer in the engine compartment. Simulated service conditions test the distributor under computer control and instructs OK units to ship out. The quality control room houses the computer which controls and surveys the many quality tests performed in the plant. All plant data is electrically inputted here and is outputted in report forms designed for control. Starting motor plants produce high-performance motors. Special material conservation techniques comprise the Delcotron motor. Building commutators starts from copper tubing sheared in a wobble press. Sheared rings are cold-formed into a special shape to eliminate separate commutator bars. Transfer to a large forming press automatically feeds rings into the press cavity. Formed rings stick to the ram punch and are stripped and ejected automatically. The formed blank must be faced and trimmed free from flash. Thin elevated wall sections are formed to facilitate separation in final assembly. The riser bar ring is pierced to receive insulation in a phenolic molding process. Tangs are cold curled inside on both ends to anchor firmly to the molding material. The ring is phenolic molded to a die-cast core on automatic pallet-type presses designed by Delcotron and are unique in the industry. After molding the ring and core, the unit is notched to receive the armature wires. After soldering and during final shaft assembly, the thin bar sections are cut away, separating the plastic insulated bars. Metal extrusion processes reduce machining chips. Motor shafts are extruded from bar stock on both ends. The center finish shaft is splined and knurled. The shaft extrusion is performed by multiple extrusion dies. The shaft is turned end for end and both ends extruded in the same press. Armature conductor wire hairpins are collated in assembly jigs and pressed into an insulated shaft and lamination stack. Projecting ends of the hairpins are further sized to enter the riser bar slot of the commutator. Commutators are fed automatically into the assembly rotomatic. Preformed hairpins from the previous station press precisely into the com slots, and the commutator press fits onto the shaft. Rotating assembled commutators are fountain soldered to the armature hairpins on solder machines. Motor frames are extruded thin on one end for material and weight savings without affecting performance. New, smaller motors are using powdered metal inner frames for material savings. The extruded frames are thinned at the commutator end. Starting motor pinions are cold-formed in headers to reduce material costs and the cost of expendable tools. The part is made in 2 stages from bar stock as shown. 5-lobe starting motor clutch shells are made from cold-formed bar stock. The blank is headed and the lobes cold-pressed. Aluminum field coil assemblies save weight and material costs and have replaced copper. Resistance welding aluminum to aluminum is not reliable, and ultrasonic welding techniques have proven to be good. The operation is fast, clean, and simple. Armatures and solenoid motors assemble on the final assembly line. Extruded frames are placed and the motor nears completion. Copper pads must be fastened to aluminum alternator heat sinks for soldering diodes. The finished assembly at right requires 3 pads. The assembly machine feeds the copper discs from preformed strip stock. The disc is placed over the heat sink and ultrasonically welded to the aluminum. 3 welder heads are required to complete the assembly. The welder action separates the disc from the strip. Large area welds require sizable ultrasonic transducers, and they highly stress resonant materials. Low-carbon case-hardened vice jaws resist these destructive forces. Alternator stator laminations are made from tube stock. The tube is formed from thin steel strip. A series of forming rolls shapes the sheet gradually into a series of shapes designed to minimize springback and promote roundness. The sheet nears completion of the tube forming line and is now ready for welding. DC welders resistance fuse a strongly fused seam. The tube is cut off on the fly and stacked in lengths ready for forming laminations. Tube stock of sufficient accuracy and thickness control is not available commercially. Delcotron was required to produce its own tube for the folded lamination process. The tubes are cut to rings, the rings are preformed flattened, and the coil slots blanked, and there is no skeleton scrap. Rings are sheared from the tubes and are ready for flattening. Preform and flattening in multiple sections and dies. Flattened rings ready for the blanking presses. The laminations are blanked as folded sheet doublets and require the development of special tools and techniques to produce a minimum of burr edge suitable for alternator lamination usage. Laminations are stacked and riveted into assemblies ready for receiving the overlapping triple field coil windings. Assembled laminations feed into the winding machines. The Delco designed and winder is alone in that it insulates stator slots, winds multiple coils, compacts, rope wedges, and high voltage checks for shorts in the same machine on a 25-second cycle. Folded blue paper insulation is stuffed into the slots to protect the windings when they are pressed in place from the rotary winding arbors. The lamination stack is indexed mechanically. After the paper is stuffed into the slot, a shear knife shears the continuous strip insulation to proper overhang length. The principle of the winder is to wind multiple coil forms on rotating arbors and then index and separate so that the coils free the arbor and may be pressed from the arbor into the lamination slots. A series of 3 lapping coil forms is created. The stator blanks index from station to station, and the blank is rotated properly to receive each new coil form series. Precise accuracy is required. The first layer of coils transfer to the stator core and are positioned in place. A forming press follows to achieve proper compacting. The second wind station performs exactly as the first, the only difference being the stator core lamination is rotated to a new position. Coils are stuffed and expanded into proper fit and placement. Again, the sequence for the third winder is such that coils are transferred from the winder and pressed into final position. Coil slots have been closed with rope and the coils ready for varnish. The stator core coil slots are firmly wedged with fiber rope. Varnish impregnation will insulate the assembly. Finished stator core assemblies are assembled on the final assembly line. Once the stator core field assembly is secure, the drive end of the housing is placed and the alternator nears completion. The fan assembly and drive pulley ready the alternator for duty as another vital part of the engine compartment. The drive pulley is cold formed from split metal. The pulley starts as a flat steel disc fastened to a hub. The thickness of the blank is roll split and separated outwards to form a V groove. The right feeder arm transfers the pulley blank to the splitting arbor, and the splitting dies open the groove. Electronic technical data file and processing machines are talking with people to make things happen. 5 PDP-80 storage and processing systems are in use for managing control circuits for machines, printing machine control logic ladder diagrams, monitoring plant engineering data, including utility usage, and input monitoring for updated progress reports. One unit is reserved for developing new techniques, such as enabling 2 processing units to exchange information without human interaction. Processors might automatically ask a big brother when molded beyond its. The mini-computer machine control service over a scale manufacturing plans involved control circuits for machines. Computers can control these functions and can be reprogrammed to alter machine behavior either remotely, input, and efficiently. Our machine is equipped with this type of control. 2 PDP-1145 computers are in use with a binary vocabulary and memory of 250 million words. One of the machines is being used to store, process, and update information on routings, tools, equipment, and machine capabilities. Updated and readily available, the most instant cost estimates and the ability to optimize for best alternatives. The second PDP-1145 is to store, manipulate, and print symbols. A rapid and accurate layout of symbols, such as required for electrical circuits or plant layouts, can be efficiently achieved. Using symbol command boards, a display file, a display plotter, and a keyboard interrogator, engineers can design circuits rapidly and store them in the PDP-1145, allowing the XY plotter to reproduce them as required. Routine drafting hours are saved for creative use. People, walking, and reaching, make things happen.